All right, Math Bridge 1 students. Today we're going to touch on the third of the four key center points in triangles and our investigation of them. Remember, while we're doing this, we're also learning about certain properties of triangles, including things like, well, today, medians. We've also learned about triangle perpendicular bisectors. We've learned about angle bisectors. We're learning about perpendicular lines. We're working with equations in slope-intercept form. It's very rich, and we're moving towards a beautiful conclusion at the end. So hang on. All right. So this particular center point of a triangle is called the centroid. It's sometimes known as the balance point, and this is a bit of trivia almost. But if you were to cut a triangle out of some stiff material, maybe cardboard, and find the centroid, and if you balance the triangle on a pin, say, it should balance perfectly if you can hold still. But to our objective for the lesson, which is not to do that, but you can if you want. Students can construct a triangle, can construct triangle medians, there's that word median, so we need to think about that, to find the centroid, and can use their observations about centroids and medians to make deductions about segment lengths. That second part is going to be in another video. First, I want to construct the centroid. And before we do that, though, I want to do a bit of review. You'll notice here that I just want to remind you that we've already found the circumcenter. It's at 6,4 exactly. And we haven't really used analytical means, but using our construction, we can see from the previous video that the in-center, that point where the angle bisectors meet, is at about 4 2/3, 5. And so I want you to observe that. And I'd also like you to think about what a centroid might be. And if you've been paying attention as we go, you might consider that it has to do with medians. Now, a median this is something that you learned in elementary school. It's one of the standards for elementary school, but we kind of leave it aside for a while, and here we come back to it. It says, a segment whose endpoints are a vertex of a triangle and the midpoint of the opposite side. Now I want you to think back to what you know from times past and see if you can remember how this is different from an altitude. We're going to pick up altitudes of triangles next week. That's going to be a whole different kettle of fish, so to speak. Okay. So our goal for this video is just that we're going to construct the medians for triangle ABC, and we're going to see where they intersect, and we're going to find that centroid. All right. So to find medians, just from the definition, we need the vertex. We have 3 vertices here, A, B, and C. They're just marked on the graph paper. It's easy to see through observation that we have this midpoint here on the horizontal line segment AC. And in a previous video, we actually went through the midpoint formula and found this. I just want to review the midpoint formula here. It's an easy one, but it's important. We should have this instinctively. And I don't memorize it myself. What I personally do is I just remember that it's the average of the x values and the average of the y values. Okay, so it helps to write down what those values are. This is 410. This is going to be 12, 2. So the midpoint is the average of the x's and the average of the y's. So the midpoint equals, I'm not going to even bother with the x1s plus x2s at this point. We did that in the last video. The x's are 12 and 4. So we have 12 plus 4, and the average, well, you divide, if you have averaging 2 numbers, you divide them by 2. That's the reason for the 2 in the denominator. Here we have the y values are going to be 10 plus 2, also divided by 2. And remember, a midpoint is a point, and so this is a coordinate pair. And 10 plus 4 is 16. 16 divided by 2 is 8. 12 divided by 2 is 6. And so I'm going to go back to the third color of green I have in my little palette here, and just take a look. Does this make sense? 8, 6. Here we're at point 6, 7, 8, up 1, 2, 3, 4, 5, 6. And it is right on the line there. Kind of nice. Okay. So all we have to do is construct those medians now, right? So I'm going to draw a median from vertex A to that midpoint I found. That's the midpoint of segment BC. Here we go. You might want to think why I'm not drawing a right angle there. Okay, now we're going to go to vertex B. Actually, I'm going to do vertex C because that's going to be the color green I want here. So we're going to go from C to that midpoint. Watch that one snap in place. And then finally, we have my darkest color green and yeah. It's not quite perfect, but it's awfully good. Here, actually, it's pretty darn good. Here's our midpoint, not our midpoint, sorry, our centroid. And I'm going to mark it in this lovely dark green shade. Boom. That's the centroid right there. What would you say it is in terms of its being a coordinate pair? Well, let's kind of take a look here. We're going to go over 1, 2, 3, 4, 5, maybe 5 1/3. Again, we're kind of guessing at it a little bit here. That's okay. 1, 2, 3, 4, 5. So we'll check. 1, 2, 3, 4. That's 4 actually, and maybe 2/3 right there. So I'm going to say our centroid is at, like I said, 5 1/3 and 4 2/3. And I'm going to write it down here. It's about at 5 1/3, 4 2/3. And come over here. 1, 2, 3, 4, 5 1/3, 4 2/3, and it's interestingly right about there. Again, we could be a little more analytical about defining our centroid more exactly. That would be a lot of work, but for now, kind of interesting. Notice those points. Notice those points. What do you notice about them? Here we're driving towards this beautiful result that I mentioned at the beginning of the video. We're not going to get there yet. In fact, we're not going to get there until our work next week with altitudes. But maybe you can anticipate where we're going. Okay? Next video, we're going to do some analysis of what we did down here with these medians.